given that x and y are two positive integers, and which of the following cannot be the highest common factor, which means we have to eliminate these 5 options. Let me start with the first option, A option, which is 5. So I understand that 35x and 20y, let me just prime factorize them. 35x becomes 5 times 7 times x, 20y becomes 2 square times 5 times y, which means I have some values of x and y such that there is no other common factor which can be taken out except 5. Then I can say that the first option can be the highest common factor. So I would prefer to choose the values like x equal to 1 and y equal to 1 because of my natural inclination towards the smaller values. Right. Now, trying this option out with this way also actually helps me understand how the second option can be eliminated because it is 5 times of x minus y. So I understand if somehow I could make x minus y as 1 and the highest common factor 5, then I can eliminate it. So now I'm thinking about what value can I take. One of the possibilities that immediately comes to me is, can I take 2 and 1? But the problem is I already have 2 as a prime factor of 20y. So that way 2 also becomes a part of HCF. So no, that's not the right set of values. But still I would want to choose the values which are consecutive because I want to bring this difference to 1. So let me choose 3 and 2. Now in 35x there is no prime factor 2, and in 20y there is no prime factor 3. So nothing else comes common, and 5 times of x minus y becomes 5, which actually is the highest common factor. Which means this option can also be eliminated for the values x equal to 3 and y equal to 2. Does that make sense? Now let's go to option C. Option C says 20 times of x. 20 times of x is equal to 2 square times 5 times x. Now, there are two understandings of highest common factors. The highest common factor is basically the smallest number the biggest number which can divide the given numbers completely without leaving any remainder. Right? From that perspective, if 20x is the highest common factor, then it should be able to divide 35x completely as well as 20y completely. Right? When I see 20y, I see that when x equal to y, then 20y is completely divisible by 20x. But 35x, when I look at it, then I see that x gets cancelled out and 35 is not divisible by 20. Which means 20x certainly cannot divide 35x, and hence it can definitely not be the highest common factor. Therefore it becomes the answer. I repeat once again, highest common factor is a number which can divide the given numbers completely, and 20x cannot completely divide 35x without leaving any remainder because 35 is not divisible by 20 like it is shown here, and therefore 20x cannot be the factor of 35x, hence becomes the answer. That's one way to look at it. Other way to look at it is that I see that highest common factor is basically the by part of a number which can be taken out from all the given numbers completely. Right? 20x is 2 square times 5 times x. When I look at this 35x and 20x, I would like to look at it this way, that x is taken care of, x can be taken out from 35x. 5 can be taken out from 35x. Now out of 35x I am left with only 7. And I cannot take 2 square out from the number 7. Which means 20x cannot become the by part of 35x. So that once again proves our point that 20x cannot be the greatest common factor of these two given numbers. But at the same time, we may have several apprehensions about options D and E. So I am also going to prove why option D and E also can be eliminated. Option D is 20y. So 20y can certainly divide 20y, which is the second number. And if I say that x is equal to 2 square times y, then 20y can also divide 35x. Right? And likewise, if I look at option E, which is 35x, then I can see 35x is anyway the factor of 35x, but it can also become the factor of 20y if the value of y becomes 7x. And hence option D and E may be eliminated and answer becomes option E.